Okay, we're going to demonstrate the pan and tilt with I2C control of the servo motors for pan and tilt, and also scanning with the ultrasonic. Now the whole kit is packed in this Harbor Freight case. So let's go ahead and open it up, see what's inside. So you can see that we have the system inside the case. Very nice. Key thing is this part. This is your pan and tilt. Okay, and let's take the whole system out. Over here, lay it in the middle. Get rid of the case. There we go. Here's our pot meter. Fits in the case. Just going to set this back a little bit. So here's our pot meter. We'll show how this works, controlling the pan and tilt with these potentiometers. And here's our pan and tilt. It's in this nice cylinder. This is all 3D printed, and we have these on our website, the designs. You can 3D print them. Okay, I want to explain the pan and tilt system. Here we go. Let's take the cylinder out. Basically, the pan and tilt consists of two servo motors, one for pan, one for tilt. Now if you look at the pan, it's connected to this cylinder, and it'll rotate like this and give you pan. And here we show the motor for tilt, and it will move it up and down like so. You can see both the back, the front, and also vertically up. And here's the pan. Now each one of these is a high-tech servo motor, and the high-tech servo motor accepts a 50 Hertz PWM with a pulse width ranging from 700 microseconds to 2400 microseconds. Any pulse within that range would move the motor shaft, and we can position the motor. So if we go back and look here, each one of these boards by Ionotronics contains a PIC 16F1825, which is a nice small PIC. It's an 8-bit PIC. And we have written the firmware so that each 1825 is a I2C slave with its own unique address, which is programmable. It's stored in the EEPROM. And each one of these is then bused through this Mullux connectors here, which bring in 6 volts. So each device has 6 volts coming in, ground, and it has an onboard regulator. It can also monitor the current in the motor. Then each board provides the motor with a signal. Each board then provides a PWM signal indicated by this yellow wire that goes to the servo, and that contains a PWM signal. So the PIC 16F1825s implement a nice PWM control, very precise, under the control of an I2C master, because these are all I2C slaves. Now, each board also provides the motor with the red wire here, 6 volts. So ground, 6 volts, and signals provided by the board. That allows each board to control the motor independently. So now we've put these motors on the I2C bus, so an I2C master such as the Pyroraptor can control them individually. This becomes very powerful. So now you can build multiple pan and tilt systems. For example, you might have them on the rover for the front and back, or any other application. For example, in a business where we can monitor different locations with this pan and tilt through an I2C bus. Now one nice feature we have is this, of course you can see the ultrasonic sensor. So the ultrasonic sensor itself is controlled by a PIC 1825 on this board, which is a small board we develop also. This PIC board gets its 5 volts from one of the other boards. As we mentioned, it has a regulator on it, and it provides the control signal for the ultrasonic, the nice control that triggers the ultrasonic to make a measurement. It reads back the pulse width, which is the distance to the obstacle, and processes it. It becomes an I2C slave. So now we have the ultrasonic as an I2C slave. Each one can have a unique address, so you can have multiple ultrasonic devices, sensors on your robotic application. Like on a rover, you can have 2 in front, 2 in back, etc. This way you can scale, put them all on the I2C bus. Alright, so that concludes our short description of the pan and tilt setup, and you can get more details on the Iontronics website. Lots of videos like this one, and detailed blueprints, references to the devices, their part numbers, etc. And all we have to do is put this in its base here. You can see the base right here. Take it out, put it in. This way, when you want to pack it in, you take it out, lay it flat, put it in the case. That's simple. Next thing we have to do is we have the USB connector from the computer. Here on the board, we have the Pyroraptor. Take a look at that. And here we have the Pyroraptor board, which is our USB to I2C bridge. So we're going to take the USB connector and hook it in. There we go. Now, so when it gets hooked up to the Pyroraptor starts to blink. That means the driver's working. We have a blinking LED test there. We're ready, set, go. Now, the Pyroraptor has an I2C bus, as you can see over here, and we have connector here for the Hiroshi 4-pin to our pot meter. We also have an I2C connector back to our pan and tilt and ultrasonic system. So everything is on the bus. Let's go ahead and show this. So we have our program here, which is the Java Pyroraptor graphical user interface. We'll get it running. Now, before we scan for the I2C bus, let's go ahead and hook up the power. To power the system, we use these power pole connectors. These are very good because they're, first of all, they're keyed. So here we have the power pole coming from the power supply, and all we have to do is line them up like so, connect them. Now they're connected. We also have low gauge wires, so we can handle quite a bit of current. In some robotics applications, the current can go very high, usually 4 to 5 amps. So in this case, though, we don't consume that much current, but we just make this a standard way of connecting. Now, if you look at this connector here, it's actually connected to, on one end, to 2 banana plugs. Let's go ahead and show that. And these banana plugs are great because then they can plug into power supplies that provide variable voltage and also limit the current. And we'll show you one right now. So let me go ahead and plug these back into the power supply. One particular power supply we're very pleased with is a Corad, and we're showing that over here. Don't have it on yet, but you can see the model number. And let's go ahead and turn this guy on. When we turn it on, you can see we're already set to 6 volts, which is what we need for the servos. Now the system here doesn't require that much current, maximum like 400 or 500 milliamps, but it's good to limit the current. And this power supply is great to have in your laboratory. Very nice, easy to program, 30 volts and 5 amps max. So let's go ahead and show another power supply that we support or recommend, for that matter, and that is if you have a AC wall adapter and you need 6 volts out, we recommend this adapter from Triad, and I'm going to go ahead and put the information over here so you can see it. This is a nice, good AC adapter and provides 6 volts DC out. Very good to drive robotics applications, including a full-up arm. So it does have a lot of current capability, and we've tested it and very satisfied with it. Nice, good system to have in the lab for providing variable voltage and also current limiting. Okay, so you can see the banana plugs down here, and this goes to our nice power poles here. Now here we have the power that goes into the pan and tilt over here. This is 6 volts because it needs to drive the servo motors, which are high-tech servo motors that run at 6 volts using PWM with 1500 microsecond for the position. You go from 1500 to 2400 or down to 700 to change the position. So now we have it hooked up And over here we're going to apply power, and let's get started with that. There we go. Okay, so we applied power. Current is about 80 milliamps. Okay, we just heard one of the servos go to its default position. Alright, so we have the system powered up, and let's go ahead and start the graphical Pyroraptor program. Okay, so now we are going to start the graphical Java Pyroraptor program. Here we go. And as you can see, the graphical screen shows up with a list of devices with for I2C. Let's go ahead and scan the I2C bus, and we see a list of devices show up over here. Let's see if we can zoom in there. Okay, so now you can see the list of I2C devices. 3A is the ultrasonic device, and we have address 3B and 3C, which are the pan and tilt, and 4E is our pot meter. So very nicely, we have this nice Java program that works with the Pyroraptor, the USB to I2C bridge, and gives you a list of the I2C devices. What we're going to do now is go to, first of all, we'll zoom out, get a good picture here, and go to the, very conveniently, we have these tabs. We're going to go to the PWM Servo. We are going to type in the address for the pan or tilt, and I'm not going to say which one it is because we'll see in a minute. So I type in the address, and then I can change the position using this slider right here. Okay, and then I have a button here that says update, and the tilt is moving. So let's see that. So you can see, let's go ahead and look at the pan and tilt. Alright, so as you notice, I'm going to go take the slider, move it in the opposite direction, and say update, and you can see it move. Let's go ahead and move it in the other way. So in this fashion, you can control individual I2C motors with the graphical interface. Let's go ahead and tell it to move in 5 seconds instead of 1 second. The field here to 5,000 milliseconds, so that we will move in 5 seconds. So it'll pace the motor to move in 5 seconds. Let's go ahead and move the slider. Okay, we're going to hit update. Alright, let's move it in the opposite direction. So you can pace the movement, with 1 second, 5 seconds, or less. Maximum is around 5 seconds. Now let's go ahead and type in the address for the pan, which is 3C. So here we're inputting the address 3C, which is the pan, and we are going to now hit the update and see what happens. So you can see it panning, taking 5 seconds. Let's go ahead and pan in the opposite direction. Okay, let's tell it to take 1 second for the total movement. Slider to the opposite direction. There you go. Let's go the other direction. This is a nice pan and tilt, because what I'm going to do right now is set the tilt to move. I can see forward, and I can see the back. Actually, I can go even further, as you can see a little down. So I can see the front and back. Nice pan and tilt system. Very, very nice. I can also look straight up. Okay, so what we've demonstrated here is the I2C, the USB to I2C bridge, which is the Pyroraptor. Okay, sitting right over here, and we have the pan and tilt, and we have the Pyroraptor Java user interface, which allows me to individually control these PWM motors that are on the I2C bus. Very nice, very capable, very convenient.